Hello, today I'm talking to Daria and Misha of DeepFloyd. DeepFloyd is part of Stability AI and has previously released a model called If, which is what we're talking about today. If is an open source replication of Imagen, which is a model out of Google research and has been presented in this paper right here, photorealistic text to image diffusion models with deep language understanding. So this model, the if model, is different in that it does not go to a latent space like Stable Diffusion, but it operates directly on pixel space. So the diffusion process is happening on pixel space, and then it works with upsamplers at the end. We're talking today a little bit about how everything came to be, how everything fits together, but the model is really cool. And if you go look up examples out of this, the productions of the model are very, very performant. Of course, now we have bigger models coming out every day, but given the time it was developed and, the size of the model and everything, it does some things particularly well. For example, text. So you can see here, all the text that's here is much better captured than, for example, Stable Diffusion 1.5 or something like this. So I think that this model has been forgotten a little bit next to all the DALLs and Stable Diffusions and so on being released. And I hope people will check out this line of research more. So enjoy this conversation with Daria and Misha, and I'll see you around. Bye-bye. Hello, everyone. Today I have with me two people whose last names I will not be able to pronounce, but for now, we'll call them Dasha and Misha of the DeepFloyd team. Dasha and Misha, welcome very much to here. Very cool what you're doing.
Hello, Yannick.
Hello, thanks a lot for having us.
So listeners, we have about like half a second or a second lag here, and we'll try to correct it in the edit, but at sometimes you'll hear like some awkward pauses. That is the internet's fault and not because we are antisocial people. DeepFloyd, there are a few names up here. What we've seen come out from you is a really great text-to-image model. It's a model that, similar to Stable Diffusion and DALL-E, I can put in a piece of text and then an image will pop up. But it has some notable differences, and I feel it gives really great pictures that do actually follow what I write. It's, for example, very good at also text, as we can see maybe on the screen there is a neon sign. This is fully created just from text, so there's no reference image or anything like this. And we see a few names right here. So maybe you can just tell us, what is the model itself called and what is it at its core? Like what's the model architecture?
So yeah, the model name deployed Eve. So we are DeepFloyd team. We are part of Stability AI. As a research group, we are more interested in multimodal neural networks, such as DeepFloyd Eve, or maybe you will hear some new networks soon from us. So DeepFloyd Eve is a diffusion model, is a pixel cascaded diffusion model. Then you want to describe how Stable Diffusion works. It's very easy to just Google stable DeepFloyd Eve, and you will see that it's model composed of frozen text encoder and free cascaded pixel diffusion models, blah blah blah. But what does it mean? We have architecture that is very similar to Imagen, and it used frozen T5 encoder as first zero stage to process text into embeddings, and after that we have free cascaded UNets that convert image from text to 64 by 64, then to 256 by 256, and to 1024 by 1024. So this is like the core idea of the architecture, but I hope we can discuss more details about how we decide to use some specific text encoders and what the difference between our model and Imagen, for example.
I can just add that the name of our model, if, is inspired by the song If by Pink Floyd.
Very cool. I was wondering.
Yeah.
Yes, I think everybody yeah.
So you pronounce it just if. That's cool. Yeah. I was wondering if it's like Image Floyd or
Yes,
something
we
like this,
pronounce.
since you're called DeepFloyd, or but that clears it up. Thank you.
Yes, I just wanted to say that there was a hint in our first post in Twitter, actually, because we changed a bit, like some words from this song.
Very, very, very nice. I did not notice, but I'll go back and see. I think the most notable difference here is specifically, whereas, for example, stable diffusion works in this latent space that is given by a VQ GAN with latent tokens. Your model specifically works on pixels themselves. So it's a diffusion model over pixels in a space of 64 by 64 pixels. Why did you choose this when, for example, stable diffusion and many models before have found that it works very well to do this in this latent space?
So it's very, very good question, because like we think that the latent space is maybe the best space we have now, because it can generate very good and realistic images without and don't have this problem what we have, like using several cascades. If some artifacts occur on the low stage, you just increase and use it in the second stage, and after that you have a little bit muddy, non-perfect, non-ideal image. And in the same time, latent space have advantage that you just need to create your base model in the latent representation, so you don't worry about the second stage and third stage in terms of compute and to train another part of model and to try to like somehow play with distribution to reduce the artifacts. But in the same time, we found that nowadays we had a lot of research papers that are based on Imagen. For example, Dream Fusion, this 3D nerve idea. So it was initially made in pixel space. Of course, you can do it in latent, but there are some ideas that have been made for pixel models, and we don't have them. So it is the first problem we have. And the second one, for example, is the image you see on your screen. For example, if you want to do the image in painting and you want to have the initial image and don't want to change it, you won't have like pixel perfect match between your original image and implanted one. So you should use pixel cascaded, because no latent model can guarantee you the ideal correctness of the output.
The fact that you work in 64 by 64 pixels and then you use upsampling models to do that, is that mainly a technical limitation by the fact that, you know, that was the biggest you could train? Or did you actually find that somehow this size of image is advantageous? Because it, right, naively, one would just say, hey, why don't we just work in 1024 pixel space if we do pixel diffusion anyway? So why do you do the 64 by 64?
I guess initially we wanted to reproduce Imagen, like, so it was the source of our inspiration, and we just wanted like step by step to reproduce it. But so, and in Imagen, on the base model on the first stage, they use 64 by 64 resolution and then upscale it to 256 by 256 and further to 1024 by 1024. So we just decided to do the same thing, but later we made some alterations from the initial Imagen architecture. I think we'll tell about them later on.
So yeah, the main reason is based on Imagen. So what we think is that uh, just not only reproducing the previous idea, they also agree with them in term of compute and efficiency of the parameters we use. So for example, the second stage we have this stage that can convert the 64 by 64 image to 256 can generate the image from scratch. How it works? The upsampled image have the augmentation. So this augmentation level have the bound from 0 to 1, and 1 mean like it's almost Gaussian noise, so you see nothing. The Imagen paper proposed it because we have a lot of artifacts and mismatch in terms of distribution of real images and generated. So this kind of augmentation help to generate more realistic image for second stage. But if you use the highest level of augmentation, it means 1, so you see no condition at all, and so you can do unconditional, just only text conditional generation using the second stage. But the quality of this image, it's really not enough. So maybe if we will train very large in terms of parameters and video RAM model, we can do it, but I think it's like idea to save the compute to separate in 3 stages.
Maybe you can go into this a bit more, like what, given the Imagen model, what were the most significant changes you made with respect to going away from Imagen?
So I hope maybe we will start what we not 100% try to replicate Imagen. So in the time where you maybe remember Edifi from NVIDIA, they made some model that use clip and T5 encoders together. So Daria will tell you, so we had this experience before them, but
at first, we decided to make some experiments on which kind of text encoder to use. So we had to decide it, and we conducted several experiments with different text encoders. For instance, we tried UL2 model plus clip, T5 plus clip, just clip, just T5 text encoders, and just UL2. And it turned out that the best result shows the combination of UL2 plus clip text encoders. So here we can see that it has the best average clip score. But even if in Imagen paper, for instance, they say that that T5 and clip text encoder, they perform similarly in terms of clip score, but human evaluation shows that T5 is better, and here is the same. We just looked at the images that were generated. So we conducted human evaluation, and it turned out that T5 is actually the best. So even here we see that with T5, the model can generate this triangle pink stop sign. And so, yes, it is. We see that there are more real triangle stop signs than in generations with different with another text encoders. And moreover, we decided that UL2 actually is very heavy, and I think that it's too much. It doesn't makes that big difference, to use such big text encoder in the model. So we decided that T5 is an optimal choice in terms of the number of parameters and the performance.
So yeah, I
Why?
think that
Sorry, if you talk about T5 and UL2 and so on, do you mean just the model architecture, or do you take the actual pre-trained model weights of these models?
We take the actual pre-trained weights of the model and like to use it as text encoder.
a frozen one, yeah.
Yes, definitely.
So yeah, the idea why we are not like a replica of Imagen by the like core idea, but making the same experiment that Edifi made, NVIDIA made in the parallel, I think, we found that in our case, we don't want to do some, I don't know, additional changes in architecture to like find something that makes our model new and find some new way to do better model using additional encoder, but we really tried it. So, but still we made several changes, but we think it's crucial to achieve the best FID for our days. So first thing, we didn't agree a little bit that unit size is not crucial. We found on our experiments that really the size is matter in this case, so the smallest model is not enough, so I will not cover here at all, but the thing I want to tell you is the difference in terms of UNet. So we found that Imagen proposed efficient UNet, the idea that maybe it's better to use more parameters and more VRAM for activation in more deeper layers, but not use them in the higher one. So we found that maybe we can do the same thing, but we rearrange it a little bit and create the optimal UNet, like they call it official, we call it optimal, why we think it's optimal. So we found the lack of cross-attention layers in the deeper blocks. So we think that information for upscalers have to be conditioned on the text. The text condition is crucial in this kind of architectures, and we think that maybe we can reduce number of blocks, but add more cross attention to the text to have a better text alignment. And we found that having vanilla UNet and optimal UNet with almost the same parameters, the 400 and 450 parameters, we cannot match them exactly because it's a slightly different architecture. We found that the loss, like MSE loss from the training this diffusion, it's much lower using this optimal UNet for second stage. So this is not the efficient UNet, but it's like own idea to rearrange the second and the third stage for this model. So this is like main difference, I think.
And what have you it seems like you've done a lot of exploration of the architecture, trying out different things, rearranging things, more layers, more attention, and so on. And if we look at your output quality, it's pretty good. What piece would you say made the biggest impact on, like, what is, if I were to just go now and build myself a thing like this without reading much, right? I just kind of try. What is is there like one piece of advice that you give to someone who just wants to go out and build something? Like, what's the most important thing to pay attention to?
Yeah, I think it's like my opinion. I think maybe Dasha has another opinion because it's like really own thing. I think the most crucial thing for me is to have the good text encoder as a T5, maybe UL2, maybe some better encoder decoder part to take just good encoder. The frozen one, we try to unfroze it. We try to train it, so we didn't succeed with that. So they think the frozen encoder, the big frozen encoder and good trained frozen encoder is crucial. And also they think that the base UNet size, it's also means a lot because it's gives more parameters for cross attention, for better interpretation, the text embedding from text encoder. For example, if you try some simple prompts, as you can see, for example, a photo of a red cube, even like Stable Diffusion or all other models that have simple text encoder can generate this simple prompt because like there is a small amount of information. But you remember the time that people try a lot of different things in terms of prompt tricks, for example, I don't know, trending on our station, yara yara, and all this stuff helps to create better image, and but by the adding a lot of stuff in your prompt. But maybe you don't want to type a lot of things, you just want simple expression. You want, for example, red cube on the top of a blue cube, and you want text blue on a red cube and text red on a blue cube. You don't want like a lot of prompt tricks to do the correct output. But for doing that, you really need good first stage, the good text encoder, and the more parameters for cross attention and to interpret this text. And for example, if you compare the results with Stable Diffusion and the Stable DeepFloyd Eve, and also Midjourney V5 with DeepFloyd Eve, you will see that it is impossible by them to create correct image. And if the main idea to understand text correctly, I think the bigger UNet and the cooler and frozen text encoders are crucial. Yeah, but I think that maybe latent is not the bad thing, because we see a lot of artifacts in our pixel cascaded approach. So we think they maybe using latent, you can combine these two cool ideas and have the best model.
Yes, and I think what also you should bear in mind, deciding which size of the model to choose, is also like the size of your data set. And it's very important to make some experiments on like scaling and to see if there is some overfitting problem, for instance. And actually, Imagen in their paper, they write that they didn't struggle with overfitting, but we are not sure about that it's true, because with the size of our model, we have the biggest model is 2.3 billion parameters, and we definitely have some overfitting issues.
And by overfitting, how does overfitting look like in a model like this? Like it would always produce the same image, or it would just fail if the text is not in the training set, or how does overfitting look?
For instance, if there is some very popular image, for instance, Mona Lisa, which you can see on different surfaces. It can be on the mag, it can be on a T-shirt, it can be as it is. So it's very hard to make some alterations with this type of image. Mm-hmm. So in most cases, you just get the initial Mona Lisa image. So it's much easier to make some alterations and variations of images if it's some like normal image with no overfitting. But with this type of images, yes, it's really just hard to get some variations of it.
I see. Yeah, I mean, it does make sense. It appears in the training set probably a ton, right? Yeah, I think so. Oh, nice.
So you can see like Mona Lisa.
I also love the
but the only one in head. So why it's so? Because it's so many time on different prints, etc. So it's just remember it by heart and cannot hallucinate it on it.
In terms of FID score, our model demonstrates the best result. We can see that zero-shot FID at 30K is 6.66. And it is actually the first score we get once we calculated it. But then we just realized that probably the process of calculating FID score, of evaluating such model, lacks consistency and transparency. We mean that there are 40K images in COCO evaluation set, right? And the zero-shot feed is calculated on a subset of 30K images. And we should also take into consideration that for each image in COCO evaluation set, there are 5 captions. So we have actually many variants of this caption text pairs, and there is no a predefined set on which every text-to-image model can be evaluated. And we just decided to look at the spread of FID scores, which are calculated on different subsets of 30K images. And on this slide, we can see that actually, like for instance, we took 1K subsamples generated with different classifier-free guidance values. 1K subsamples of these 30K sets of images. And it turned out that there is a huge difference between them. So, for instance, FID at 30K minimum score is 6.58, and the maximum value is 6.76. And the problem is, if you look here, we can see that Imagen has FID score 7.27 and Party 7.23. So we can see that the difference is in the second number, second sign after comma. So it means that, and we don't know on which caption and image subsample of this 40K COCO evaluation images is calculated FID for Imagen or for Party. So it means that it can be not statistically significant, this difference between Imagen FID score and Party FID score. Because here, for instance, the difference is even in the first number after comma. And we think that probably it's better to have some predefined set of images on which all text-to-image models can be evaluated, or probably it is better to show some mean score, for instance, to have 1K subsamples of this 30K sets and report some mean score. But we think that it makes sense just to make this procedure clear and consistent.
Maybe adding some, I don't know, fixed data set, subset of these images. Because it's very hard to ask people to recalculate it for all 4K. It's historically made for using this random subset in 30K. So it's very hard to ask people, okay, now we decide to use all eval set from Coco, but maybe just fixed for future some subset that should be fixed. And yeah.
But it's not even perfectly clear why do we use 30K samples. I mean, we can use like the whole evaluation set. Why not?
But it's historically, yeah, it's
Yes.
made historically. So we don't.
Yeah, but probably we should change it because it's a bit mess in calculating FID score if you read different research papers. So, yeah.
So it could very conceivably be that some of these other models, they just got lucky or unlucky with their choice of subset, and then yeah, it could be that I'm honestly surprised how still, I mean, I get it that there is an ambiguity and so on, but overall I'm still surprised by how reliable the FID metric as such still seems to be, because the metric is really old, right? And it uses, if I'm correct, it uses this Inception v3 or v4 network to somehow calculate a distance to reference images. I would have guessed that with the rise of such good models that produce images, it would be kind of a meaningless metric until now. But it seems to be still the fact that, okay, you know, as sort of models get better perceivably by humans, they also get largely better in this FID score. So there still seems to be a bit of a direction in this, which is cool to see. But I totally see your point of maybe we should fix the subset. Maybe you could do that, right? Maybe you could make a little paper that says, hey, here is a new benchmark that's fixed and so on. And then everyone, I mean, it takes someone to say, look, here is what we do from now on. So, you know.
So this is very old metric that show just the similarity of distribution of generated images by these captions and Coco image. So if you use some prompt tricks, for example, you add like the old photo from internet from 2014, it will be even close to this Coco data set because it's very old and made in 2014. I mean, yeah.
Cool, excellent. And you also have some cool generations, I hear. So maybe we can get into that a little bit, because I've already seen some very cool ones on the website, but I'm very sure you have the best examples.
Yeah, these maybe a few things I can cover. It's what we want to show that model can generate not even photorealistic model, but the model with good text understanding. The photorealism is here. It's very yummy, very real, like a photo. We also made the model that can somehow generate the fingers. We trained it before Midjourney version 5, so we see that Midjourney made a lot of effort and work to generate more proper hand, but it's like a good test, like Voight-Kampff test from Blade Runner for this kind of models. Now we can do hands. This is not a good test anymore. They can also generate a good text on the images. Very realistic with some. Maybe it's easy to add this kind of text in Photoshop because it's just straightforward, even this. But if you want to do maybe some print on your t-shirt or even on your head, you need.
So yes, you can like add a texture in your text. Yes, if you would like it to be as if it is embroidered on some clothes or made of some stained glass, you can do it with the model. Yes, and we were a bit surprised to find out that our models show some multilingual ability. Where is it?
I don't know.
Sorry
I
for
really
that.
don't know.
It's somewhere there, somewhere here. Yes, it turned out that the model, it's definitely because of T5 text encoder. The model can understand some text in different languages other than English, but it is some European languages, so we can't, our model can't understand some text from some other linguistical branch. But it understands some European languages such as German or French, for instance. Here we can see that it perfectly generates black cars, whether you would like it to be in German or in French. Also with, so we can see that it clearly understands colors and some simple objects such as cars, for instance. But it also does quite well with some long descriptions, actually. So here we have this description of an appliance or compartment which is artificially kept cool and used to store food and drink. And this is definitely a fridge. And we can see that the model understands it, even if this long description is in German or in French. And it's very funny that if you put this description in German, the resulted images are empty fridges. They're also whether empty, whether full of some bottles, drinks, probably beer, because as we all know, Germans like beer. Yeah, whether when you use English or French prompts, you see fridges that are full of some vegetables, some meals, and so on. Yeah.
Which is especially interesting, because if I understand correctly, you do train the model on a subset of Lion 5B that is mostly just English captions. Is that correct?
English only.
So it's even more, even more special that it then starts to really understand, or that it does really understand these cross-lingual things, which is quite cool.
Yeah, true. And here is some fun example, but it actually shows that like the tokenization isn't perfect. Here we can see like a green apple and a black backpack. And we see that in French, this word backpack is sacadou, but like the bag, just some women bag, is sac. So we see that on these generations, which comes from French text, we see only women bags and no backpacks. Yeah, and one more interesting example. So a national, if you put a national dish, you really get some national dish. And if you put this prompt into our model, so in German it's ein Nationalgericht, but in German Gericht is also a court, but this word Nationalgericht, it relates only to a national dish, actually, because as far as I know, the word like a national court is Nationales Gericht, I think, and it's two different words as far as I know. But here we always get a national court, a building of a national court. Yeah.
That is it's super interesting, I have to say. Yeah, especially considering that the fact that it sort of learned this aligned embedding from the T5 space, or the T5 space has somehow this learned embedding space, and then it's essentially an English generator on top of this embedded space. Yeah, so I can confirm that, being a German speaker, that Nationalgericht is usually just a dish, and the court would, like, the word national would probably not even appear in most cases. So yeah, but it's still like I just needed to laugh when I saw that, because it's kind of so obvious why the model makes that mistake, but it's still like super interesting that it does. So yeah, very cool. You said before that you don't need that many prompt tricks and so on. Do you have recommendations for people who want to use this model? What's the best way to prompt it? Like, what's the best stuff to put in the positive prompt, and what should I put into the negative prompt, and something like this?
So what I just want to tell what I found by generating different stuff. My friend make these like image. Dev will come and she will have your eyes. He spent about 1 maybe 2 hours to generate it. So because there is a lot of text on it, and it's very hard to generate such a huge amount of text. So what he did is to add this text several times in the prompt, like about 3 times, in different quotes, in 1 quotes, in 2 quotes. So I don't know if it really helps, but adding text several times really helps.
And sometimes it helps to quote some concepts. For instance, you would like to make some scene with some several concepts, and if you quote like this concept to make it more like separable, sometimes it also can help to get the result that you want much faster.
The models, you said they come in different sizes and so on. If let's say I'm some home user, some hobby user, I have maybe a large gaming GPU or so, what's the biggest model that I can conceivably run as a single person, and what do I need for the biggest model to run?
So yeah, for nowadays, I think that if you have like your gaming PC at your home, for example, 4090 RTX NVIDIA with 24 gigabyte GB of VRAM. So what you can do, you can use the largest model we have. You have the Excel stage 1, so 4.3 billion parameters. So you can do classifier, free guidance, diffusion in the same time without any like wiggling with it. So you can just generate the correct image in the first stage, the second stage, and use your frozen T5 encoder. But if you not so like lucky to have this kind of gaming PC, so there is a lot of hacks that Hugging Face team made. So by even using free collab, you can use deployed if model with the largest way. I mean, choosing the biggest based one, like second stage, and the upscaler. Now we didn't release our own first stage, but you using model architecture.
Our own third stage. Yes, we haven't yet released the second upscaler model. So yes, but it's possible to use it with stable X4.
So with offload and some stuff that were made, you can use just free collab if you don't have your own PC, or just Hugging Face space to generate some images.
Cool. yeah, let's talk about releasing the model a little bit. So this is currently released on the hub, at least the first and second stage, right? The text encoder is an existing one, and is specifically released under a non-commercial license for now. There's also the paper is still coming out. What are your plans for releasing this? I have heard at some point, it's gonna be made available later under a commercially friendly license. What are the considerations there? Why is it not just fully commercial right now? Or what are what's kind of the thinking behind the release process here?
Yeah, it's a very, very hard question. It's more about like legal stuff and the stability. So now we had a compute and ability to train the deployed model, and really happy to share with the community. So the way how we can do it more step by step. It's the way where we can first of all do initial alpha testing. This initial alpha testing include 100% that try our model and found some like pros and cons. We found some non-safe issues with our model, and we fix them by changing the data set, by also adding some filters on the online training phase and also on the inference phase. So we try to make our model as safe as it can be for releasing it to like commercially from the stability. And now we are on a stage where we can give an access for all the people around the world to try our model, and also for researchers. For example, we found that by using deployed if model, there is some concepts that were originally made for Imagen, for example, Diffusion, are already made for deployed if, and this is some repository you can find and try this model. It's also using our own license, right? Because to generate this kind of text to 3D, you have this part deployed if inside, and you need to agree with this license. And this is now it's like research only, but we hope that like gradually with the stability we can do it like more open and even commercial one. And also we have some ideas in the future to release the next generation of if.
Maybe on the topic of stability, what's not clear to me quite yet is your relationship to Stability AI. Sometimes they do sponsor compute, sometimes they are shareholders of company, if I understand that correctly. Sometimes it's just a loose association. How does the DeepFloyd team and Stability, how do they work together, or what's their relation there?
So we are like part of Stability. So Deployed Lab is just part of Stability. So
Yeah, like
Okay,
Carper
that's
AI,
cool.
for instance.
yeah, the same.
Yes, and some other teams. Harman AI.
And yeah, is there do you have, how much freedom do you have to decide what to research on? Like, can you do what you like? Can you have your ideas, or is there like a very top down, like, oh, you now need to do this text to diffusion model? Or how does that come to be? Because it's a very special situation. It's open source, but it's also a company, and there are a lot of researchers involved. So I'm very interested in how that works. How do you get to decide what to work on?
So yeah, this is was our initial discussion with the mod. We had an idea to create these open source large pre-trained models. So we found that it's like our common ground here, that Stability want, but the same thing we want. So we decide to be part of Stability and do this stuff. And by deciding the core idea and using like the pixel cascaded diffusion in the same time where the Robin and his team made the latent diffusion, we are doing so one more text to image model in a parallel, very similar one, using almost identical data set. And all the decision we made in team was our internal decisions. I think we have a lot of freedom, but the only thing what we want to do altogether is to releasing this kind of model and do have this kind of model to find the compute on them. So I think we have huge freedom in terms to decide what to train and how to do this architecture and how to make it, but also we should to train it properly and do the best to open source it.
Yeah, we really appreciate that. Yeah, we really appreciate that within Stability we have really great research freedom to choose which architecture we'd like to use, which decisions we'd like to make. I mean, in terms of optimization. And Stability really is happy to provide us compute and like the main goal of Stability and of like our team is to release in the end some open source models.
Excellent. So last question from me. Given you have this model now, there is a release process ongoing. I'm going to guess that's more on the side of the legal team and so on. What is next for you? What is next for DeepFloyd? Do you want to continue this line of research? Do you already have some higher goal in mind, or where are you going?
So yeah, now we finish the deployative model. So we try to think what we do next. We have several ideas how to do next gen text to image model. We also have some ideas about maybe working in another domain of multimodal architectures, but for now we are thinking that maybe one of the streams will be to continue doing these open source state-of-the-art text to image models. So we're thinking to doing if too.
Yeah, and it's cool that within Stability there are several teams which are specialized on different domains. For instance, there is a team that works with the sound, there is a team that works to images and so on. And so we can cooperate with each other and try some multimodal architectures.
Cool. Is there any last thing you would like the community to know, or you would like to get out there about your model, about your team, or just about the general direction you'd like to see in the community?
So yeah, as a team, we will be happy to see maybe more ideas how to use deployative model, if it's possible to see maybe some pull requests and ideas how to optimize it. And maybe we will try to do some stuff more with the community, maybe some open train, like how it can be done. It's a very hard question, but maybe we will try it. So definitely come to our Discord server. We don't have like some bot and free generation there, but there is some group and discussion, so we will be happy to talk.
All right, that's excellent. Well, Misha and Dasha, thank you very much for being with me today, and this was an absolute pleasure.
Yeah.
Thank you, Yannick.
For us as well, thank you.